Okay, today we're going to add like terms in what are called rational expressions. And especially in the last, about 10 lessons, we've been talking about these things called rational expressions. And I don't want you to be intimidated by that term, because rational expressions, all they're really saying is a rational expression is simply a situation where you might have a type of fraction. So this right here is a rational expression. So if we're adding rational expressions, it might look like something like this. Here we're adding two rational expressions. Now today we're going to talk about how we add like terms in rational expressions. So I've got two examples, and I'm going to go through a couple different ways how to do each of the two examples. So don't get locked into thinking that there's just one way to do these problems. Now before I continue, let's make sure we understand what we mean by like terms. If I had 2a squared c plus 3a plus 4ca squared. Now, here I have three terms, don't I? Remember, terms are something that are combined or connected by plus and minus signs. Now, here I have three terms. Now, are any of these like terms? And the answer to that is yes. This one and this one are like terms because they have the same combination of variables to the same exponents. So in both these terms, I have a squared c. Now here it might not be in that same order. It's ca squared, but it's still the same. I could write it as a squared c. So the two terms that I have two lines underneath are like terms. And remember, it doesn't matter if I have what the number is in front there. So now I can combine like terms. So for example, 4 plus 2, I have 6 of those a squared c's, and then finally plus the 3a, which is unlike, and I've simplified this. All right, let's take a look at example 1. And in example 1, I can see I have a rational expression. So in other words, I have two terms where they're fractions. They're in fraction form. And I'm going to simplify these by adding like terms. Now, traditionally, how you would try to add these is that, first of all, we'd try to write all the exponents positive. That's one method. So as you look at these two terms, can I tell if they're like terms? You know what? I can't tell if they're like terms because they're not written the same way. So somehow we got to see if we maybe do have like terms. So one method is to rewrite everything with positive exponents. So as I look at this, I'm going to have my fraction bar plus my other fraction bar. All right, now I'm going to notice the a to the negative 3 on the top here. Okay, I'm going to drop that down and it becomes a cubed, doesn't it? Now I'm going to move the b to the negative 3 up and it becomes b cubed. And then I still have that b to the first, really, that's still on top. And I left the b in top because b means b to the first, and that's a positive exponent. Now over on the right hand side, this one right here, do I have any negative exponents? No, so I'm just going to leave it as 2b to the fourth over a cubed. Now what you're beginning to see is I really have like terms here because both of these are over a cubed. Now I'm going to simplify the top left one. B cubed times b to the first is b to the fourth over a cubed plus my 2b to the fourth over a cubed. And now you're starting to see that I have the same combination of letters, which means that these really are like terms. So, and really, to tell you the truth, I don't like this method as much as the second way. I'm going to show you how to do this. So here I have two of them, right? Now here is not a number in front, so really I have one of them. So I have one of those b to the fourth over a cubes plus 2b to the fourth over a cube. So I have 3 of the b to the fourth over a cubed. I have 3 of those, and I'm done. I've combined these. Now, as I said before, I don't like this method, and meaning this method is, remember how we did this. We wrote everything with positive exponents. I'm going to go over method 2, and probably to me this one makes the most sense. And in method 2, what I'm going to do is kind of the way I've explained it to you in the past. Anytime you have the fraction bar, and remember when I say the fraction bar, it means this. Simplify the top, simplify the bottom, and then move everything up. All right, I'm going to use this method. So, is there anything to simplify in the top of this one? No. Anything in the bottom? No. So now what I'm going to do is I'm going to move everything up. So I have a to the negative 3 in top. I'm going to move my b to the negative 3 up. It becomes a b cubed. And then I still have the b. Plus, now over here on the right side, I'm going to move everything up. So 2a to the negative 3 and then the b to the 4th. Now I'm going to simplify. So here I can simplify my b. So I have a to the negative 3, b to the 4th, plus 2a to the negative 3, b to the 4th. Now, remember, there's a 1 right there. So I have 1 of those a to the negative 3, b to the 4th, plus 2 of those a to the negative 3, b to the 4th. So I have 3 of those a to negative 3, b to the 4th. So to me, that makes a little bit more sense. And depending on what the directions ask you to do, they may ask you to write the final answer with all positive exponents. Well, I can easily do that from this answer. All I'd have to do is drop my a to the negative 3 down, and so my final answer, and I'm going to put this in a different color, would be 3b to the 4th. Drop my a to the negative 3 down, it becomes an a cubed, and it's the same answer as what we had in the first way that I did this. All right, let's take a look at the final example. Now, in the final example, I'm going to do it the way that I like to do it, because I feel like you're going to understand a little better. So let's take each of these terms. Here's a term, here's a term, and here's a term. And let's first of all look at these three terms. Are any of those like terms? Well, it's kind of hard to tell, isn't it? Because there's so many things going on. So since I have fraction bars, I'm going to simplify the top of each one, simplify the bottom. And you know what? In each of these terms, there's nothing to simplify in the top. There's nothing to simplify in the bottom. So I don't need to do that step. So next thing I'm going to do is I'm going to move everything up. All right, so I have 7a to the negative 3, b squared. Now move my c to the negative 1 up. It becomes a c to the first. Minus. Now move everything up in the next one. So I have 5. I'm going to try to write this alphabetically. Put my a's first, then my b's, then the c's. So I'm going to move my a to the negative 3 up. It becomes an a cubed. And then I still have my b squared, which I leave alone because it's already in the top. And then move my c to the negative 1 up. It becomes a c to the first. Plus 3. Move my a to the third up. It becomes a to the negative 3. Then I have my b squared. Move my c to the first up. It becomes c to the negative 1. Now look at these terms. Is there anything to simplify in each of these? Is there anything to simplify here? No, there are a, b's, and c's. There's nothing that are the same there. I can't combine anything. Nor can I here, nor can I here. All right, so next thing, are any of these like terms? Let's see. The first one is an a to the negative 3b squared c. This one is an a to the positive 3b squared c. The third one is an a to the negative 3b squared c. So the ones that I have with two lines underneath are like terms. I can combine those. So I have 7, put this in a different color, I have 7 of these plus 3 of these. So I have 10 of the a to the negative 3 b squared c's minus the 5 a cubed b squared c. And I'm done. I cannot take 10 minus 5 because those are unlike terms. One of them is an a cubed, the other one is an a to the negative 3. So, remember, if they want you to write it with all positive exponents, let me erase part of this. Remember what you would have to do to that a to the a to the negative 3. So if they want you to write the final answer with all positive exponents, what I would do is I would drop this down. So I'd keep the 10 in the top, I'd keep my b squared c in the top, drop the a to the negative 3 down, it becomes an a cubed, minus my 5 a cubed b squared c. And I don't have to do anything with those because those are positive exponents. So this would be another way I could write the answer with all positive exponents. So this is called adding like terms with rational expressions.